Hello students, in previous video we have seen a linear regression. Now in this video let's see a nonlinear regression. Nonlinear regression. In previous section we have used simplest type of relation, that is linear relation between the correlated variables for predicting the value of dependent variable for a given value of independent variable. The prediction is reliable when the square of the correlation coefficient r square is large enough. If r square is small, the linear regression will be of no use for prediction of the value of dependent variable, that is, no linear relationship between them but the curvilinear relationship, that is second degree, exponential and third degree, etc. Such a relationship is called a nonlinear regression. Okay, what I say, the prediction is reliable when the square, you know that the square of correlation coefficient is the determinant coefficient, right? Correlation coefficient of determination is this, is large enough but if r square is small, the linear regression will be of no use, for prediction of the value of dependent variable. That is, no linear relationship between them. But curvilinear relationship that is second degree, exponential, third degree, etc. Okay, such a relationship is called non-linear regression. The method of evaluating the unknown constants in the equation using a bivariate data is by the principle of least square, and the procedure is known as fitting of regression curve. Here we study two types of nonlinear regressions. First, second degree and second exponential. Adds y equal to a into b raised to x and y equal to a x raised to b. These one. Okay. The method of evaluating, here these a and b are constants. These one. Method of evaluating the unknown constants. In these equations. Using the bivariate data is by the principle of least squares and the procedure is known as fitting of the regression curve. Okay, so now first of all let's see fitting of second degree regression curve. Let y equal to a plus bx plus cx square, call it as equation number 1, be the second degree parabola. To be fitted to the bivariate data where a, b and c are constants. A, B and C are constants to be determined using the principle of least squares. Using the principle of least square, using the equations summation yi is equal to n into a plus b into summation xi plus c into summation xi square. Okay, then summation xi yi equal to a into summation xi plus b into summation xi square plus c into summation xi cube. Then summation xi square yi is equal to a into summation xi square plus b into summation xi cube plus c into summation xi raised to 4. These equations we can use. Okay, while simplifying these three equations, we have these values from these bivariate data, that is summation yi, summation xi square, this product summation of this product also. All these values with us. Only unknowns are what? ABC are here. N is also known to us. Okay. Solve these equations. Solve these for A, B and C. And then put in 1. Put in this equation 1. We get required second degree regression curve. We get required second degree regression curve. Now here one more thing you should note. For simplification, in calculations, shift the origin means what? Deviation. Shift the origin of x. Shift the origin of x or and y also. Origin of x and of y or and of y, that is u equal to what? X minus a, where a is what? Assumed mean. This one gives us the simple values for calculation, right? So that these equations can be easily simplified. If required, we can shift both the variables, we can deviate both the variables, or if required we can use any one of them. Okay, so let's take an example on it. Here the question is that fit a second degree parabola to the following data taking y as dependent variable. The data is given, the values of x and y are given here. Okay, so let's simplify it. Now here note first, what is x bar? X bar is summation x upon what? N, and summation x is here 15. You can check 15 upon 5 will be what? 3. Now for convenience of computation, let us transform x to u by transforming, take a deviation about mean. Okay, for convenience of computation, let us shift this x to u by u equal to x minus x bar, that is u equal to what? X minus 3. Okay, now the equation y equal to a plus bx plus cx square, the equation a plus bx plus cx square expressed in terms of u will be will be what? Y equal to, suppose, a dash plus b dash u plus c dash u square. Okay, it will become as such. Our independent variable is previously x, as we have to consider y as a dependent variable, but now we have been changed it to u. We are changing it to u, right? So due to that, our equations also changes. The normal equations are, therefore the normal equations are the equations to find these constants a dash, b dash, c dash. So they become summation y. In place of x we have to use u. So summation y n into a dash plus b dash summation u plus c dash summation u square. Again summation uy is equal to a dash summation u plus b dash summation u square plus c dash summation u cube. Again summation u square y is equal to a dash summation u square plus b dash summation u cube plus c dash summation u raised to 4. So we need to simplify, we need to obtain all these sums. So for that, let us prepare a table. The table has first of all x, then u. U is what? X minus 3, right? So finding u, okay? Then y. We need y, right? Then we need summation u square. So let me find u square. U cube, u raised to 4. Let's find out all these, right? Then also we need uy and u square y. These one we are required. Fine. So x are the values. What are the 1, 2, 3, 4 and what? 5. We need sums of all these, right? So let me write these things whenever required. U will be what here? Minus 2, minus 1, 0, 1 and 2. And this sum will be what? 0. What is y? Y is given to us. 2, 6, 7, 8 and 11. And this sum is how much? 34. Then u square. 4, 1, 0, 1, 4. 1, 4. Okay. And this is how much? 10. Then u cube is minus 8, minus 1, 0, 1, 8. And that sum will become 0. Here u raised to 4. So 16, 1, 0, 1 and 16. So that is how much? Again 34. Okay. U into y. So minus 4, minus 6, 0, 8 and what? 22. And that sum is how much? 20. Now u square y is 8, 6, 0, 8 and 44. And that sum is how much? 66. So these are all about the table. Now put these values in these equations, these normal equations. Therefore, what we get? The normal equations becomes, the first one will be summation y is how much? 34. So 34 equal to, that is n is 5, plus b dash into summation u. What is summation u? 0. So 0. And c dash into summation u square is what? 10. Right? Then next one will be summation uy. What is summation uy? 20. Equal to summation u into a dash, summation u is 0, right? So 0 into a dash plus summation u square is 10, 10 into b dash plus u cube, this sum is what? 0, 0 into what? c dash. Next one, 66 equal to what? U square, so 10 a dash plus 0 b dash plus u raised to 4 is how much? 34 c dash, right? This is same as 34 equal to 5 a dash plus 10 c dash. This part will become 0. These parts will become 0 here, right? Call it as equation number 1. Then 20 equal to what? Simply 10 b dash. Equation number 2 suppose. 66 equal to 10 a dash plus 34 c dash. Equation number 3. Okay. These one. Now simplifying these or solving these equations, we will get the values of a dash, b dash and c dash. So now from 2, equation 2 gives us b dash equal to what? 2, right? Fine. And solving these two we can solve simultaneously for a dash and c dash. Solving 1 and 3, I had solved it. You can solve on your own. We get the values. By solving them, we get a dash equal to 7.0857 and c dash equal to minus 0.1429. You know how to solve them. Make the coefficient of one of them equal, then either add or subtract whatever required according to that, and then eliminate one of them, get the value of other, put that obtained value in one of them and get the value of remaining one. Fine. Hence the equation of regression curve is what? Y equal to 7.0857, right, plus 2u minus 0.1429 u square. But we have to determine an equation in terms of x and y, not in terms of u and y. So put u equal to what? X minus 3. So x will be what? So from that we get x is what? U plus 3. So sorry, u will be x minus 3. The same value we have to put. Sorry for that. U is x minus 3. That value we are substituting here. Therefore, put u equal to what? X minus 3. Y equal to 7.0857 as it is, right, plus 2 into x minus 3 minus 0.1429 into x minus 3 square. Simplify it. After simplifying, we get here y equal to minus 0.1999 plus 2.8571 times x. You can simplify these one. Okay, do a square and take a product and all. Simplifying, we get these. Remember it. Minus 0.1429 x square. This is the required equation of that parabola, that is second degree parabola. Okay. Next example. Next example we will take in next video. So thank you.